Okay, so welcome to the webinar today. We're going to be talking about some flow control options. Um, it's generally automated flow control. It's all based on FMH products, obviously. So if there are other products around there that the general architecture will be the same, but principles will be the same. But this is based on PowerFlex and to some extent our Best Connect products. I'll generally be talking around parcels because that's the industry we prefer. But yeah, we should get some good information from here. These are a number of flow control options we've developed over the years, and they all have different functions. So we'll talk through those, and we'll have a Q&A session at the end. So if you have any questions that come up, if you can use the Q&A feature within Zoom, if you just post on there, some of them will be answered by text immediately, and some will keep to the end, and I'll try and answer them live on the show. Right, so let's get into this then. So flow control. What you can see here is obviously it's a flexible conveyor, but it could be any conveyor really. We have a very simple setup. We have, just use the highlighter here. So we have a very basic PLC. We commonly use a Siemens logo. We have some sort of sensor at the end. We have one relay or motor contactor just to turn all the motors on and off. And they all turn on and off at the same time. Obviously, you can get issues with inrush current, all that sort of thing, turning all those motors on and off. There's some of the disadvantages, but this is a very simple flow control. So our packages they'll basically come trundling down the flex. When the first package hits the sensor, there's a small time delay normally between hitting the sensor and the motors turning off. But we essentially turn all the motors off at the same time. If somebody's there, they take the package off and the motors can restart. And that's pretty much it. That happens over and over again until the conveyor is empty. We're normally building a time delay on the relay that prevents chatter on the contactors. So we have a small time delay for stopping and a small time delay for restarting. Also allows you to get, if you do have a queue of boxes along here, it allows you to get that box off without another 50 boxes trying to push you over. So you take away that line pressure. So next we have what we call build back. I'm actually drawn in a gravity decline. I'm using the same drawing, but if you can use your imagination there, that this is running downhill. So we have the same kind of setup as we do with a package stop. There's only one sensor, one relay, one basic PLC. But now the photocell is back from the end a little bit. So what we can see here is the package is building up. And eventually that photocell is covered. Again, we're building a time delay. I don't want it stopping every time a box passes over it. So we have to build in a time delay based on speed. And also we need to make sure it's a common error. The photocell must be in the gravity decline part. Otherwise the system won't restart by itself, which we'll see after that time delay, the motors stop. But if you don't put the sensor in the right place, when you get that restart, it won't become uncovered. So it has to go in the gravity decline. And when that restart happens, the motors start up again and it all carries on. Because you've got that time delay in there, if you've got someone there constantly emptying that section, then the motors don't stop. It doesn't stop at all. So indexing, this is getting a little more interesting. The applications are a little more interesting. So now we have two sensors, one at each end of the conveyor. All the motors are all controlled one relay, all starting and stopping at the same time. So the same negatives that you might have there. So indexing is when the start sensor initiates the motors to move. So when it's in index mode, all the motors are off. The first box comes in and it starts the motors off. And when it sees the tail end of the box, the motors then stop. So one of the advantages here is you get a constant gap between parcels independent of the parcel size. So what you get is what I would refer to as a maximum fill rate. So if you've got two small parcels and one big parcel, you're getting the most amount of parcels onto your conveyor at one time. So when we switch to a package stop mode, all the parcels move to the end sensor, and then we can start removing them. Let me back up a bit. So just to say, when both of those sensors are full, then we get a full signal. Now that can be a light or a flashing button or an audible alarm, but it will show that the whole thing is full. It could also be an output to a system, SCADA system or something like that. So now we're combining two different systems that we've talked about already. So we have 3 photocells. We have the indexing system, which we've just seen, and that's combined with a build-back sensor. So essentially, we don't do anything until that build-back sensor is activated. We're just in normal running mode. So all the parcels will run down, conveyors running normally. Now, when that last section is full, nobody's there to empty it, or there's some sort of build back there, then we tell the rest of the conveyor to switch into index mode, start accumulating. There's nobody here to take the parcels off. So that's when we start to index. So then we can fill up that whole indexing section while this guy is on a break, or sorting out some parcels in the truck, or he's dropped a box of wine or something. So, whatever that problem is. As soon as that's taken off, the build-back sensor becomes uncovered, and it automatically switches from index mode, and all the parcels move down as normal again. So we're expanding on that same idea, but we're adding indexing sections. So we're kind of splitting a longer conveyor into zones. So we have a number of index zones, each controlled by a separate relay. And the trigger to tell these zones to index is that build-back zone. So we've done systems of this where we have an operation at the end of a long conveyor line, something like a weigh scale or a packing line or a scan. And if that person can't keep up with the flow, if it's normal, the input and the output are balanced, then the conveyor just runs as normal, no start stops, none of the disadvantages that come with that. When it fills up and the person can't keep up with their work, or they've met a problem, or they've had to leave, then the immediate zone upstream starts to go into index mode. And then we start to fill up. Now, the rest of the zones, however many there are, they're all just running normally. They're not starting and stopping. It's only this one. When this one's full, i.e. both of the sensors are covered, then this next zone upstream starts to accumulate. And as soon as this zone becomes uncovered, then everything goes back into normal running mode. We don't need to accumulate anymore. The problem's gone away. The person's back at their station. Next up, we've got increasing complexity all the way through. You can see now we've got multiple relays, multiple motors. We've got one central PLC. That's normally the architecture we see on a flex. Obviously, there are other things we can do on fixed conveyor. There's 24-volt technology where we use separate control cards with separate 24-volt motors. You might end up with one card controlling 2 or 4 zones, but in this case, we're using our normal DC motors and they've got an onboard relay. So the PLC receives all the information from the photocells and then tells the relays when to turn on and off. Normally, we're stepping up from a Siemens logo here up to something a bit more substantial, probably a 1200 series PLC. So singulation release. This is always one that's difficult to explain. The difference between singulation and train release. I'll have to admit, I've been at this for about 30 years, trying to explain this one from the early days when I worked with Interroll and we were developing the 24-volt technology. There were 2 versions of release, and trying to explain the differences is a difficult thing. Hence the animation. Hopefully, this will make it easier. Essentially, what you get is the parcel runs through, it stops at the sensor with the leading edge. The system doesn't care about the size of the parcel as long as it's not bigger than the zone. Otherwise, you'll be covering both sensors and you end up with a stop situation that can't be released. In this case, with singulation release, the first parcel is taken off, and then each parcel shuffles down. Essentially, each zone only looks forward to the zone in front. It can't see any further than that. If we look to train release, which is starts off the same, it's got the same architecture, the same parts, but the release is different. The restart is different. So in this case, when that first parcel is taken off, everything moves together. Hence the name train. Everything moves just like a train does. Now, disadvantage of this one, you do get big inrush current again because you're turning all your motors on and off at the same time. So that could be an issue. And inertia. You can see here that it flexes on wheels. If you don't have all the brakes on and you've got a lot of inertia on the top of the conveyor, it could be when you get that big restart that the conveyor goes one way and the parcels go the other way. That can also be an issue on fixed conveyors where the legs start to flex because of the inertia at restart. So sometimes you do train release and then break the zones up a little bit, or you build in some sort of time delay on the motors so that you don't get all the motors all starting at once. It's worth noting if we're talking about throughput, so the train release is twice the speed of singulation release. So that all of them are sort of dependent on the size of the parcel, the size of the zone. It's not really conveyor speed that makes the difference. It's the speed at which they're moving downstream. And train release is twice the speed of singulation release. So next thing, very simple this time. We've got one sensor. We're talking about jam detection. Typically, it's at jam points, around merges, anywhere you've got a 90-degree, slides, those sorts of things, you would get a jam detection. We don't commonly use it on a flex, but it is possible. So a parcel gets jammed, maybe it's jammed between side guides, it's too big, something's happened, piece of strapping on it or something. Then the next parcel comes into the jammed one and the sensor stays covered. Normally, we're looking at a much longer time than you would see on something like a build-back sensor. We've done projects in the past where it's anywhere between 10 seconds and 45 seconds. Obviously, the 45 seconds, that's fairly long. That's a long time to see whatever damage might be caused by that jam. So you have to kind of balance it between not stopping too often and the damage that may be caused. Normally, we clear the jam and then hit a reset button, and that kind of restarts everything. one last part, obviously, we saw a lot of sensors in the presentation so far. We have to match the sensor to the application and to the product. The material to be handled is normally for us is cartons and poly bags, that sort of thing. So it's fairly straightforward. But we also do things like tires, plastic molded parts, it could be anything. And you really do have to pick the sensor for the right application. The most common one for us is to use just a diffuse scan sensor, which is in a bar looking up through the rollers. Diffuse scan sensors are okay, they're pretty good. The range can vary depending on lighting conditions, that can cause some problems. But for the most part, it will see the box and everything will work fine. Because we're looking up through the rollers, what we can do here is have an oversized box. So the box can be bigger than the conveyor and hang over the edges. So that can't be done on our next option. If we have a retroreflective, so we have a sensor and a reflector, we're now breaking a beam, so you're much more likely to get a good positive signal. But now we have parts, the reflector on one side, the sensor on the other side. Now we have parts that are sticking up above the top of the roller. So the sensor position has to be wider than the biggest box. And you can't put anything wider than that. So you're creating obstruction. Next level up, we'll have a through beam sensor. So we have a little story from the past. We had a customer that was using retroreflective sensors, which was fine until they started putting a silver label on their product. And the silver label acted as a reflector. So we were getting all sorts of weird signals, and we had to go and change all of the sensors to through beam. So it really is, you've got to be careful about the application. Here we get a good positive signal again. One of the points about a through beam sensor is we can now be safety rated. There's a lot of changes at the moment around EN 619 and safety rating, performance level rating. This type of sensor can be rated at performance level C. You can't really go much above that with an optical sensor, but a through beam sensor can do that. Then we're looking at arrays and light curtains. Array sensors are fantastic for irregular parcels. If you've got a box, this is probably overkill. If you're putting all sorts of parcels down, garden spades, for instance, we have actually seen that happening. A garden spade, obviously, you've got a change in profile, it's a change in height. Sometimes it's on the belt, sometimes it's sitting 3 inches above the belt. The array sensor is actually several sensors stacked one on top of the other. So you end up with a larger range of vision. You can also set array sensors so that it can ignore some products, a belt, for instance. If a belt is moving through that array, you can tell it to ignore anything that's only covering one of the lenses, that you need a 2-lens cover to take the signal. So that's quite a useful thing. Obviously, they're more expensive. You've got multiple sensors in one stack. And if you're doing safety devices, obviously something like a light curtain is that's required for any higher performance levels. If optical sensors aren't going to work for you, so things like tires, we did one project in the past where we had it was plastic molded fuel tanks, which were black. They had multiple different textures on them. They were a very weird shape. In that case, ultrasonic sensors are fantastic. They work, just like a bat hearing. It sends out a signal and detects whatever comes back. In the same way you can do with light, this does it with sound. The advantage there is it doesn't matter what color it is. As long as you've got a solid surface that can reflect backwards, ultrasonic sensors will work. They are quite a lot more expensive than optical sensors, mainly because of the quantity that are made and its use in the market, but they work pretty well. And especially if you've got an odd shape and an odd material. Even if it's see-through, sometimes none of the optical sensors will work if you've got something made of glass, but the ultrasonics will work on any solid surface. So that's pretty much the end of my presentation today. Timing looks about right, so we're at 25 minutes for a half-hour session. That gives us a good 5 minutes of Q&A if we have any. So on to the questions section. Just see what we've got. So are there any options for multiple functions on the single conveyor? Yes. We launched a year and a half ago, I think it was, we launched. So we can have a flexible conveyor with all of the functions on. It's built like a ZLP. We have all the sensors of a ZLP because that's the kind of the higher level. But you can have a selector switch that turns ZLP off if that's not suitable for the application that you're doing. So you can have it zero line pressure for part of the day if you need it singulating parcels, and then you can use it for another application and another part of the day. You change the operation and now put piles of parcels on, or you put on longer parcels that ZLP wouldn't work with. But yeah, you can just have this 5-position selector switch, and that gives you an option to do anything you like for any application. So yes, that is possible within our products, yes. So if the conveyor has ZLP, but the operator manually moves between zones, what happens to the logic? So that's really good. ZLP doesn't have the visibility that a human does, obviously. So if you remove a parcel, it just knows that the sensors are covered. So there'll probably be some sort of time delay in there, and then the system will try and reset itself and everything will move forwards. Problem happens really when you have, not with train release, but mainly with singulation release. If you have a large parcel covering two sensors, then the system can't restart because you've got 2 zones covered. The previous one can't move forward because the zone in front's covered, and both zones will end up in a stationary condition, and it can't clear unless you have a manual intervention. So for index dieback, what happens when a longer parcel crosses over into? Yeah, I mean, the longer parcel for index dieback, longer parcels will be just seen as a series of long parcels. I mean, it could even come as a slug of parcels, but again, it only sees sensors on, sensors off. So a long parcel will be seen, let's say it covers 2 sensors in a single zone, then it will immediately trigger the upstream to start accumulating. How does flow control make the conveyor more efficient? So in a normal conveyor, that's exactly what flow control is about. In a normal conveyor, it just runs. So the motors are running whether there's a parcel on it or not. What we can build in is sleep modes. So if there are no parcels, no activity, we turn the motors off. You don't use electricity. You don't wear out the parts in the motor. So that is a really key part of flow control. You extend the life of your product. You pay less for your electricity. We're saving the planet, 1 sensor at a time. That's quite a good thing to do. Yeah, I think that's probably one of the main reasons for doing that. Obviously, it's better for usage as well. If you've got nice flow control, you're not just getting parcels falling off all over the floor. Each parcel's presented one at a time. It's a much safer way to work. So how many sensors are on a standard sensor bar? So that really depends on width. Within our Flex product, if we have the diffuse scan sensor or looking up, we normally base it on what we might see on a typical material to be handled. If it's a normal 300 wide box, we would put maybe 3 on a narrow conveyor up to 5 on a wider conveyor, something like that. But they're pretty low cost, so the cost impact is minimal. If you are handling smaller parcels, or not necessarily smaller, but less width, we can increase the array of sensors. We can close that pitch up on smaller widths, we can add more sensors in. Any health and safety implications with ultrasonic sensors? Oh, I'm not aware of any because they're ultrasonic. Unless you have like dog hearing, it probably shouldn't be an issue. But I'm not aware of any, no. And can we connect with existing conveyors on site? Absolutely, yes. So quite common is to have some sort of machine plug. So we share our signals with other conveyors and vice versa. We have shared emergency stop zones. But yeah, it's pretty common, certainly for flex conveyors. It's kind of standard practice now that we have an interface plug. Normally in a project that's agreed up front, we know what the interface is going to be and what the pin allocation is. Obviously, we're going to share with someone else. So we've got 2 controls engineers who make that agreement, and yeah, everything normally works fine. I think that's all the questions all done now. So we're at we're 1 minute over. How's that for timing? That's not bad at all. So thanks for everyone's time. I hope it was useful. If you have any questions, feel free to contact us. You can get in touch with me directly, or any of our sales team will be available to answer any questions. If it's a general question about flow control and not specifically our product, I'm happy to answer anything. Get in touch on LinkedIn or anything like that. So that's pretty much it for today. So thanks for your time. I hope it was useful.